So we're asked to factor completely 4p squared q minus 16pq plus 12q. As always, our first step is there a greatest common factor? So we look at the coefficients first, 4, 16, and 12. What's the common factor in there? Well, it would be 4. And then there's not a p in all three terms. There is a q in all three terms, so we can factor that out. And that leaves us with p squared minus 4q times 4p would be 16pq. And then that's plus 3 because 4q times 3 is 12q. So then we want to ask ourselves, with the trinomial that's left inside, we have a leading coefficient of 1. So now we can just look at, are there any values that multiply to 3 that add to negative 4? Well, if there are, we know that our leading terms in both binomials, our leading term in both binomials is going to be p. And then it's going to be minus and minus because we're adding the 3, the constant, the last term, but we're subtracting the 4p's. So the only way that that's going to end up working is if both are subtraction, because negative times negative is a positive. And then when we add them, we want them to be negative. And the only way we're going to have that happen is if they're both negative, since we have the trailing term being positive, and then we're subtracting the middle term. So this is going to be 3 and 1. And the binomials that are left will not factor any further, so we'll go ahead and check our solution by multiplying through. So this would be 4q times p is p squared. Outside is minus 1p. Inside is minus 3p. And then the last term's negative 3 times negative 1 is plus 3. So that equals 4q times p squared minus 4p plus 3. Then distributing the 4q, we end up with 4p squared q minus 16pq plus 12q. And that is what we started with, so our solution checks. And our factored form of the original polynomial given is 4q times p minus 3 times p minus 1.